Hello guys, we are looking at our unit circle and using that unit circle to complete worksheets A, B, and C, which are posted on our course page. So a few things you need to know. The reason the unit circle is our own little calculator that we're going to memorize and know for next year is we can use it instead of the calculator to solve questions like on those worksheets A, B, and C. So first of all, sine 90 degrees. So a couple things we absolutely need to understand about the unit circle. Remember, we always start measuring from this positive x-axis. Positive angles are in this direction, negative angles are in this direction. Okay. Secondly, the x-coordinates. The x-coordinate of any point on the outside, any of these special places on the outside of our unit circle, the x-coordinate always represents the cosine of the angle, and the y-coordinate always represents the sine of the angle. Now, how are we going to remember that? Stop for a second. Stop the video for a second after I explain what you should be doing. And think about ways you're going to be able to remember, always, that the x-coordinate is cosine of that angle and the y-coordinate is sine, that you'll never get these two things mixed up. Okay, so stop the video, think about it, and then come back. All right, so if you stop the video, then you can use your way, whatever way you figured out. That's called a good way to remember things that you figure out how you're going to remember. Or you may want to use this idea, alphabetical order. So x coordinate, y coordinate happens to be in alphabetical order. X comes before y, and cosine comes before sine. If we think about it alphabetically, C comes before S. So that's one way. There's several other ways I've heard about doing it. So whatever way works for you, but make sure you will never get mixed up. X coordinates represent cosine of the angle, y coordinates represent sine of the angle. So let's go to number 1 on worksheet A, the sine of 90 degrees. So at sine, we're going to be looking for a y coordinate. Okay, so we come to our unit circle. It's a positive angle, so we're going to go in the positive direction. 90 degrees. 90 degrees brings us to here, okay, from here to here, and then takes us to this ordered pair, which is 0, 1. Okay, so therefore, the sine of 90 degrees is that y-coordinate. It equals 1. If you then poke this in your calculator, you would get the exact same answer. Okay, make sure you're in degree mode because it's in degrees, and you poke sine of 90 degrees into your calculator equals, it'll equal 1. All right, sine of 5 pi over 4. So looking at 5 pi over 4, we need to be able to find that place on our unit circle. So 5 pi over 4. So pi over 4, remember, means we are dividing each pi, so half of your circle, which is pi over here, into 4 equal parts to be pi over 4. So this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4 will bring us here. And the ordered pair for that spot is negative root 2 over 2, negative root 2 over 2. Okay, so the sine of 5 pi over 4 is the y-coordinate, negative root 2 over 2. All right. Second fact, we haven't talked about this yet, but super important to know, is that the tangent, where can I write this? Tangent of any angle is actually equal to the sine of that angle divided by the cosine of that angle. This is actually one of our important formulas. It's in your formula booklet. Tan of theta equals the sine of theta divided by the cosine of theta. So when we look at number 5 on worksheet A, the first thing we have to do is say, oh, this is equal to sine of 5 pi over 4 divided by cosine of 5 pi over 4. Okay, so important to put that step in there. Now we can look on our unit circle. It's the same place we just did for number 3. So it's over here. Sine is the y coordinate, so negative root 2 over 2. Cosine is the x coordinate, so negative root 2 over 2. And one number divided by itself is just equal to 1. So the answer there is 1. All right, sine of negative pi over 4. So a negative angle, remember, goes in the negative direction. So we could think about this in a couple ways. Where is negative pi over 4? We can think about, okay, well, where is positive pi over 4? And that's up here. So this angle has to be exactly equal to this angle. Okay, positive pi over 4 angle has to be equal to the size of a negative pi over 4 angle. That will bring us down here, which is root 2 over 2, negative root 2 over 2 for our ordered pairs. Sine represents y coordinate, therefore our answer is negative root 2 over 2. All right, hopefully you'll be able to do the rest of those. Now let's look at worksheet B, please. So worksheet B, here we have tan of 9 pi over 6, okay? Now that fraction can actually be reduced, so let's reduce it. This is the same as tan of 3 pi over 2, because 3 goes into both the numerator and the denominator there, okay? Tan of 3 pi over 2, so think of your unit circle. Where is 3 pi over 2? Well, we have to start counting from here, start measuring from here. Positive angle, so around here, and 3 pi over 2 brings us as far as here. The ordered pair is 0, negative 1. Okay, now let's remember tan is sine over cos. So tan 3 pi over 2 divided by cos 3 pi over 2. Sine of 2 pi over 2, the y coordinate is negative 1. Cosine of 3 pi over 2, the x coordinate is 0. We cannot divide by 0. This is undefined. Okay, so does not exist. There is not an answer for that question. All right, let's look at worksheet C now. Number 1 has to do with, they listed a few points. So we have this point, negative 1/2 root 3 over 2. So we need to find that point on our unit circle. So let's find that point on our unit circle. Negative 1/2 root 3 over 2. So thinking of our unit circle, negative 1/2, so that's in this direction, negative 1/2, root 3 over 2, so that's as high up as we go. So this is negative 1/2 root 3 over 2. Okay, what quadrant is this in? Well, this is quadrant 1, 2, 3, 4, so it's in quadrant 2. And yes, we use Roman numerals to represent the quadrant. Okay, the sine of theta at this point is root 3 over 2. The cosine is negative 1/2. And the tangent will be sine over cos. Okay, we have more work to do here. We cannot leave this answer like this. If you get something like this, we need to do out that math. Okay, this is the same thing as saying root 3 over 2 divided by negative 1/2. Remember, when we do division, we keep the fraction, the first fraction as is. We change division to multiplication, and we flip the second fraction. Okay, you might want to, instead of putting an x here, it's probably better to put brackets around here, because nothing in between those brackets means that we are multiplying. Okay, all right, there we go. Now let's simplify. Multiplying fractions, multiply across the numerators, multiply across the denominators. Negative 2 root 3 over 2. And we can simplify. Since everything in the numerator is multiplied together, we are allowed to what we call cancel. And our answer there is negative root 3. All right, down here in another part of worksheet C, something to think about. Okay, something called periodicity. 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 That means I can keep actually going around and around and around the unit circle, and those ordered pairs are still representative of how big that angle is. Okay, so in other words, if I have this unit circle here, and I knew that this point from our last point here that we just talked about in number 1, this is, what angle is this? It's 2 pi over 3, or 120 degrees. Let me just make sure here. 1, 2, 3. 1, 2, 3. 1, 2, 3. There are the ordered pairs for those. Pi over 6. Pi over 3. Yeah. Okay, so 2 pi over 3. All right, so this is 2 pi over 3. From here to here is 2 pi over 3. Also 120 degrees. So let's talk about degrees first. So the sine of 120 degrees is root 3 over 2. The cosine of 120 degrees is negative 1/2. Okay. If we make another rotation around that unit circle, starting here, go all the way around, which would be 360 degrees, plus 120 more. Okay, so plus 120 more, so 360 plus 120 is 480 degrees. Then we also know that the sine of 480 degrees equals root 3 over 2, and the cosine of 480 degrees equals negative 1/2. Okay, and we could make as many rotations around there as we want, keep adding 360 degrees. If we are doing this in radians, then we would add the radians. So in this example, this is 2 pi over 3. So 2 pi over 3, if I'd make one full rotation around again, add 2 pi to that. So 2 pi over 3 plus 2 pi, one other rotation. So that would be 2 pi over 3, get a common denominator, so 6 pi over 3. That would be 8 pi over 3. So we could also say this is equal to sine of 8 pi over 3, cosine of 8 pi over 3 will also be equal to those same numbers. All right, so let's go down here. In worksheet C, number 7, cosine of 600 degrees. We have to figure out where is 600 degrees. So, there's the unit circle. One full rotation will be 360 degrees. Another full rotation would be 720, so we're not going that another full rotation. But how much further are we going? So 600 subtract 360 is 240. So we're going 240 degrees more. So one full rotation plus 240 degrees more. 180 is there. 60 more is 240. So it's this position on our unit circle, which has negative 1/2, negative root 3 over 2. And we look for the cosine, which is the x coordinate. So the answer to that is negative 1/2. Okay. The sine of negative 13 pi over 4. So again, worksheet C, looking at number 14, the sine of negative 13 pi over 4. So we need to think of our unit circle again. Negative angles, so we're going in this direction. All the way around would be 2 pi, and 2 pi is equal to 8 pi over 4. Right, equivalent fractions, that's true. So we've gone 8 pi over 4, and we need 5 pi over 4 more. So this would be 4 pi over 4, 5, it would be up to here, where this place is negative root 2 over 2, positive root 2 over 2. So the sine of negative 13 pi over 4 is positive root 2 over 2 from that point. Have fun with that, guys.